Alright, welcome back. 30-day scripting challenge, day 28, entry 28, and I'm recording this the day after 27, which is how it should have been this entire time, but I've not been doing that. I'm a very not time management person. Okay, anyways, besides that, day 28 has to be one of the easiest things ever, and judging by the setup I already have shown here, it should be obvious what we're doing, but this is the only setup I've done before recording, and that is making the objects here and also change the color of the checkpoints from like day 7, I believe, because I didn't really like how they're just gray parts. I made them green. Anyways, if you couldn't get it, it's pretty much a procedural generation system, and it's super easy to do, believe it or not. A lot of things I say are easy to do. This one, I really mean it when I say it's easy to do, and I don't think this should be a very long video to make, but essentially, all we're going to do is we're going to get the start position, of a room, and we're simply going to align that with the end position, the previous room, and we're going to get the C-frame of that, so that way we can pivot the entire model using its pivot. So pivot to the exact movement that we need to get the start position here to the end position. It's really simple. And also, I forgot that I need to change this into a model, not a folder. But yeah, we have 5 different rooms. We have a forward, we have a right turn, we have a left turn, and we have an up and a down to add some nice elevation there. So I real quickly got to turn this into a model here, not a folder. Alright, so now that they're models, they'll actually move together, as you can see. So anyways, we're really probably only going to use one script for this, and oh my computer is lagging right now. Oh no, it's just my OBS lagging. Okay, very simple. So we're going to put this into the replicated storage because I'm not really using it, and we're going to make we literally only need one script for this. Literally only one. So first off, we need to obviously get replicated storage because that's where our rooms are. And from here, we have all of our rooms, and we can just access them however we need to, right? Okay, let's now get to the main part. So obviously, we need an initialization, and in this, it's going to be called by our entry point. In here, we're going to call all of our main stuff here, but essentially, we're going to make a main function, which I have decided I will use a local function or internal function. But since in the last video I did use a local function, we'll use a local function. And because it, we'll keep the name scheme correct. So when we run our generate rooms, we obviously want the amount of rooms to generate and a optional delay if we want to have it look nice. So that'll be a number, and the amount will also be a number. And from there, the function will take itself from there. So to begin, we first need to actually get our start position. So I'll do that. I have a thing in here. This is the first start, because we're gonna have the start change every time. Workspace dot start, and pretty much what we're going to do is we're going to put it in a loop. So I'm gonna put it in for I 0 to 1, 2, and we're going to start. We're gonna start picking the rooms to generate. So the first thing we need to do is pick the actual rooms. Right, so as a matter of fact, I need to actually, because I know this is going to be in a procedural generation thing, but we need to have a module script. Actually, no, we'll do it inside the generation here. So the local criteria or room data is going to equal this, right? And in this room data, we want to store all of the rooms that are going to have a certain restriction, essentially. So I have an up and I have a down room. Essentially, we can't have those two rooms spawn in front of each other, or else it'd be like a hill, and we don't want that. Though you'd also want to include this for things like, if you're actually making a game with procedural generation, you'd want to make sure you don't get like an outdoor room and then an indoor room when it needs to have like this whole outdoor section, essentially. But anyways, that was actually a bad example. But in here, we want up, and that's going to equal to a table, and in this table, the rooms that it can't spawn against is simply down, right? It can't spawn next to a down room. And the same thing will go for the down. It literally cannot spawn in front of an up, and that's it. So if it finds this thing, it's going to look inside of the table and it'll see the down thing. So in this case, the name of that room is the same thing here, so it'll do that pretty nicely. So we'll make a variable local found is going to equal to false, and while not found, put task.wait there. All we're going to do is we're simply going to say, also we need a selected room. We're going to set selected room to be the rooms folder, and then, oh wait, actually no, it should be this thing. And then the string is essentially going to be the math.random1, comma, the number, rooms folder, get children, or I think this actually should work. And essentially, all we're going to do is, I also want a previous room, by the way, and we're simply going to check if previous room, then, and we're going to look inside of our rooms blacklist, and we're going to see if the selected room has a blacklist with a previous room. So in this case, our selected room is up, so we're going to see if room blacklist, selected room, then if previous room, or if table.find previous room. No, sorry. Right, so we're simply going to look inside of the blacklist table and see if the selected room is in there. So in this case, up would be in there. And we're going to look if table.find, because it's set to a table here, the previous room, .name, actually, previous room is a model, and a selected room is a model. Then we're going to just return, because it does not work, and we're just gonna have it check again until it gets a room that will generate correctly. Right now, by the end of this loop, we will have our room. From here, we can do the logic. We're simply just gonna make a function to move the room, or actually, we don't even need a function to align the room. Honestly, we can just do it right here. It's quite simple. Essentially, all we need to do is we need to get the previous room's end position and the new room's start position, right? So say local previous end position is going to be the, oh actually no, because if it's a start, then we want the start, so is equal to, oh, actually we can just say previous room and previous room, find first child room end, or workspace dot start. That'll do it. And then the new start position is simply just going to be our new room, which in this case is the selected room, find first child, start. And then from here, we can simply just run our pivot logic here. So essentially, the first thing we need to do is we need to get so in the previous video, I was talking about the delta, which is simply the change in, and we use that for when we're dragging the UI around. In this case, we need to find the change in the C-frame between the previous room and our current room. So essentially what we can do is we can make a variable, and we can call it like the offset from start, right? And we're simply going to use the get pivot function to get the primary part C-frame, because this is because the primary part C-frame is deprecated, you use get pivot, right? And once we have the actual pivot of our object, we're going to use :to object space, which is going to return the transformed from world to object space, right? So we're going to transform this into its object space. Instead of local space, we want the object space. Or not, what the heck? Instead of world space, we want the object space. So the object's rotation, where it's facing, etc., right? And we're going to pass in the new start dot frame, in which case the new start here is, oh, what the hell? Rename them wrong. And we're going to get we're passing the new start position, the C-frame here for the to object space. And that's our offset that we're then going to multiply. So when you're manipulating C-frames, they don't exactly have subtraction or addition like vectors generally have. They have multiplication and division, essentially. So we just want to apply that offset to our model now. So the target C-frame is the previous end dot C-frame times the offset from start, and we're going to use :inverse, which will simply flip it around so we can actually move it towards it instead of away from it. And now we can just say new room, or our selected room, :pivot to the target C-frame. And we'll say if delay, then actually if we have a delay, then we're simply just going to do that, right? So now when our function is called. Sorry, I was thinking about doing something else there, but when this is called, we're just going to say, what am I doing? My typing is off today. Generate rooms. Our amount, we'll do 20 rooms, and we will wait 1 second, or we'll do 0.1 seconds, or 0.5 seconds between each room. So now, on our entry point, we'll simply just call generation, and we'll say generation.init. So let's go over here and let's simply run it and see how it turns out. Okay, so I did that wrong here. The way we're supposed to do it is we need to turn this into a :get children, and this will already do that for us. Okay, I didn't parent it properly. I didn't even clone it. Oh my goodness. Oh my. So now we're going to actually, there we go. And now I'm actually putting it in workspace. Am I doing this wrong? Yeah, it's getting the right. Oh, that's why. No, that's not why. Right, if the previous room, there we go. Okay, so it doesn't look like it's moving it at all. Okay, forgot to set the previous room. There we go. Okay, whoa, okay. Let's run it. What the heck? Is it spawning under them? Dude, what? Okay, it looks like my positioning logic is wrong. Okay, so essentially, I think all we actually need to do is just change the orientation of the end point here. So all that looks like is we're going to go here and we're going to turn on the show orientation indicator and see how that's front. Yep, that's good. And then the front here, show orientation indicator, front. That's good. Make sure it's facing the correct way. So yeah, so here, this would need to rotate. This would need to rotate a whole 180 degrees. Oh yeah, also it looks like the indicators are all wrong. Or not indicators, sorry, the rotations are wrong. Wait, this is going up, right? Yeah, so, yeah, you're good. These actually were correct. Wait, this is down. No, those aren't correct. Okay, what am I doing? Alright, so you're facing good. You're doing good. What's that? So this faces correctly, Good. Okay, so now that the actual orientation is correct of the positions only, not the actual room, the room is fine. We can put this back and run it again. And yeah, that appears to have generated nice. So obviously, having a thing going down and going up is obviously going to mean that it'll generate into the floor. So we obviously don't want that. Let's try giving this 20 now, fix the actual problem. And you can see the paths generating here. So it looks like looking pretty good. And looks like we ended right here. So two things that obviously need to be fixed is essentially not generating into the ground, which I know you're not going to be generating a layout into the base plate. You're obviously going to do it in like a void area or up in the air. But the issue essentially would be having a pathway generate on itself, like having 4 right turns essentially. So to essentially what is the filler words, right? I mean, basic English. This is a procedural generation script from here, right? But if I crank this thing up to 100, actually let me go into run here. I'll show you what is going to happen essentially to the thing, right? We start here, right? And to just break. What the heck? Why did it stop? Did I only what? So eventually you can see here that it overrided. It collided with itself right here, which is what we don't want, and then it just stopped. Yes, it selected up, which you can't do from it down. So also that's another error I'll have to fix. But like you see right here, this is the main issue. It went in a full circle around it, which it shouldn't be able to do essentially. So what we can do is we can pretty much just go and make a recursive backtrack to make sure that if it does make a collision in its path, it'll just rewrite the rooms. However, if you are having the rooms generate on command essentially, then you want to predetermine, pre-make the layout of the, let's say I'm making a doors game, right? You want to pre-generate the entire layout and then unload everything and just load each door as the player goes. So that way the layout won't interfere, the player doesn't go into a door and then they can't really recursive backtrack it, or else the player will just fall into the void or whatever. So anyways, Actually, we can get rid of this start because we're already using workspace.start. So essentially, all we're going to want to do is we want to make a table and store all of the spawned rooms. And this entire generate rooms function, right, as cool as it is, it's not going to fit the recursive backtrack. So we're just going to delete the entire thing. We'll keep the blacklist, but we're going to delete the entire function, right? When we're making a recursive backtrack, we need a check to make sure that the room's actually overlapping with another room, and also a function to actually generate the recursiveness of not generate the recursive, like create the recursive generation. So let's actually start with the recursive generation part entirely. That's the main. So function generate recursive, right? And the inputs are generally going to be the same. We're going to want to keep our delay essentially, right? And we can actually, what we first want to do is we want to get the candidates to actually generate, right? So when you say local candidates, and we're going to want to make a function to actually shuffle up the rooms folder here, and we want to pass in a table. And that table, so I'm just going to copy it using table.clone, and we're going to loop through that table. And what this will do is it's going to swap around the elements in our shuffle, so that way backtracking can try a different order in case the first time it fails. So we can say shuffled and pass in that rooms folder. And in case this doesn't work, we're going to take a snapshot of it to fall back to, just in case it doesn't work. And also, the way we're going to use our recursive generation is we're going to pass in a remaining amount of rooms to generate that our code will then try to run and troubleshoot in case it doesn't work. So in that case, we can simply just pass in equal to 0 then, meaning we generated all the rooms successfully, right? So from here, we'll do the actual room generation. For underscore template candidates we can simply say if the previous room and the room blacklist. This is for making sure that. Also, I realized that in that while loop I did in the previous iteration, it's not return, it's continue, because it was in a while loop. So that literally ended the code entirely there. That's why I was stopping here, because I was supposed to use continue, not return. I forgot about that. So this is the blacklisting portion, where essentially did not mean to do that here. So we're now going to run our if table.find rooms blacklist, the template.name, which is our current room, and the previous room name. Then we're simply going to say continue instead of return. And this is the blacklist portion, meaning you don't want these two rooms to spawn next to each other. So now we'll grab the room model, template, clone, and set the parent correctly, and then do the same logic for the previous end and then new start. Then we're simply going to do the alignment. So same thing, local offset start will be the room model. We'll get pivot to object space, send that CFrame times the offset from start inverse. And also, when you're actually I already did that. I was gonna say that CFrames don't use addition, they use multiplication. Then I remember I did say that. So now we need to actually get our overlapping check. So we're going to make a function to check if we're overlapping. So at the top here, we say local function is overlapping. We want to pass in the room model to check if it is overlapping with anything, and that could be anything, by the way, or it could just be rooms. So for underscore part in the room model get children. In this case, I'm not going to use get descendants. I'll use get children, because the room's model is all parts. The children are all parts, not models itself. Whatever, we'll just say get descendants anyways, just to get that more sporting, because get descendants goes inside the children of the model, because in this case, that's the wrong one. Rooms here. Each room is just parts. That's it. There's no model inside of a model or folder inside of the model. So if you get descendants, but I'll do it anyways. And we'll check if the part is a base part, because if you have models or folders inside, you don't want to get the folder in the model. You want the parts only. So if not part is a base part, then continue end, and we can ignore the start and end positions because those are only collided for aligning rooms. So if the part.name is equal to the start or part.name is equal to end, then we can continue. Those are our exits there. So now to get if it actually collides, we're going to use this function called getPartsInBox, which will literally return all the parts that are colliding with a box. So essentially, we're just going to get the size of the part and we're going to shrink it down like a tiny bit because we want to, like, we can allow some collision, but not a lot of collision, right? So we'll say local hits is going to equal to workspace colon get parts in box right here, and it takes in the CFrame and the size, so it returns an array of parts whose bounding boxes overlap in a given box, and a bounding box is a box that covers the entire model essentially. So we're going to pass in the part.cFrame and the part.size, and we're just going to shrink it by like 5% essentially. So a slight shrink. So underscore hit in hits, we're going to check if the hit colon is descendant of the room model, then continue to end because we don't want to register itself as a hit. And now we're going to loop through all of the rooms. We're going to check if the hit is descendant of a spawned room. And if it is, then we're going to want to return true, because this is simply going to pass out a boolean if it is overlapping or if it's not overlapping. And then at the end here, we can simply just return false because they're not really overlapping. So back here, we're going to select if not is overlapping, and we're going to pass in the room model. Then we're going to set the previous room to the room model. This is the rest of our logic here that we're continuing. And then we'll insert into our spawned rooms room model. And if to delay, then we're simply going to s.wait, get to delay. And then we're going to check if our deeper chain has succeeded, the deeper chain of recursiveness has succeeded. Then we're simply just going to return true, so that way the success kind of like goes back up and the generation continues. So we say if generate, oh, I spelled generate recursive wrong, by the way. Recursive with an if generate recursive, and we're going to do remaining -1 because we're trying to go to the previous one, right? The previous instance. In this case, if it works out there, we're simply just going to return true, and it'll kind of just like elevate itself to the top essentially. If our recursiveness fails, we're simply going to say room model destroy, because we don't want to use that. We're going to go to a different one, and we're going to remove it from our spawned rooms table, and previous room will equal to the previous snapshot because we're going to reset back to the right. Now if it is overlapping, we're simply going to say room model destroy. It's overlapping, we're going to discard it and try the next candidate. So the difference here is that this part here is the deep call, meaning like this portion here, where if this is returning true, then all the future iterations of this will return true, essentially. If that does not work, then we're going to destroy it, meaning that has failed. So this is what's going to continuously, like, recursively generate, essentially. And if that deep call fails, then it's going to move on to here, where we'll reset and try the next candidate, essentially. And if this entire, like, recursiveness fails, then we're going to return false. And every single candidate has been exhausted, which is going to tell the previous call to backtrack. So now we can go ahead in our init function, and we can say local indent. Local success is going to equal to the generate recursive, and we'll do 20 rooms, 0% cooldown. So if not success, then warn error generating rooms. And that's it. We're done. So, and it's still being called here, and this is how we're essentially going to make sure that our rooms don't collide with each other. So let's run it. Looks like I made a mistake. Wait, let me move this into the sky and see if something's interfering with it there. Okay, yeah, actually I have no idea what's going on there. Gotta put the true there. Don't want to return false. Okay, let's go up here, run it, see how that works. Nope, that's still not the problem. So I think the issue might be that it's actually flagging the previous room as a collision. Like this part here. Though we're only spawning in one room. Maybe after, like, it's trying to spawn this next room in and that's failing. So say if placed is equal to previous room, then continue and run it. And I think that's the issue. Yeah, that was the issue. Okay. So it was flagging the previous room. So now here we can see, is that 20? Here, let me actually, parent. There we go. So let's go on ahead and see. Actually, let's go to run. I think it runs like F9 or something, or F7. I don't know. Okay, so yeah, the issue was simply that it was flagging the previous room as a collision, which is what we didn't want to have happen. Alright, let's see here. Yeah, that is indeed 20 spawns. So yeah, I mean, I think it works pretty nicely here. And if we simply don't want it to collide with the base plate, simply just check if hit name is equal to base plate, then return true end. because if you don't want it to collide with the base plate, then we'll simply just do it this way. And I'll bring it down just enough so that there's room for it to generate below it, but also so that it won't collide with the base plate. Yeah, like that, basically. Okay, yeah, I'll move it like perfect. There's plenty of room here. So if it tries to generate into the floor, it's not gonna work. And wow, it generated itself straight through the main area. So actually, if you want to take it another step further to make sure that your generation doesn't pass into a specific area, what we can do is we could put an invisible wall here, an invisible barrier, essentially, like this, right? And actually, I gotta turn camera here, right? And we'll simply just call this the barrier here. And I'll actually go on ahead and I will grab you and I'll move you outside the gen barrier here, just like that. And now it won't. Oh, actually, wait, the initial position actually matters. There we go. Nope, not working. Okay, I don't even know why that broke it completely. Okay, yeah, I mean, that's pretty cool room generation. And now from here, do whatever the heck you want. Make it as crazy as you want. Here, you know what? Let's give it 200 rooms over 0.05 seconds. There's a lightweight room generation. Actually, I don't think it's lightweight. Okay, now I've got to put the comma. And let's run it and see how crazy it'll turn out. Oh my god. Oh my god. Oh my god. Wow. Okay, so if we analyze it here, I actually believe that it worked very well. I don't see any collision anywhere. Actually, wait, hold on. Let me go and play test it here. I don't think there's a single collision. I literally, there's no collision anywhere. Oh shoot, I forgot this guy. I forgot he existed. The boss from, what was it, like 25 or something? Yeah, he throws fireballs at you. About that. Yeah, there's no collision anywhere. Hey, that's not a collision. This is not a collision. There's no colliding here. I don't see any colliding. Alright, and then that goes around, and then it goes under here. Yeah, look, there's no collision. It might look like it. And if you wanted to make sure that there's space, you'd put like a you put like a hitbox, essentially. Well, not a hitbox. You would put a barrier box to increase the size of your path to make sure that it does not collide. A collision box. Wow, this is actually crazy. How the hell do you switch to the server? I don't like this new UI. I don't know how to. Oh, here we go. Toggle client view. So I'm right here, right? Yup. Look at that. Look at that. Look at that. Look at that. Yup. And it ends. And if you wanted to, you could simply make a thing that has your what's it called? That has like a end thing, like a special room for the end, if you want that too. So like if the current room is equal to 1, 50, 99, whatever, you put a special room there. Yeah, okay, so now to actually make this look a bit nicer, we're gonna pass in a function. And then yeah, this little thing here will basically, when things done generating, only 5 seconds, clear everything, and regen, basically. So you can watch it here, and error generating rooms. Okay, what happened? Oh, that's right, I moved this into the ground. I forgot, yeah. If you move it into the ground, then it will not generate properly. So there we go, right? Rooms are generated. Now it's just going to wait, it'll do everything, and it'll go back to generating a new path. Does that pretty cool? And also just to make it faster, I'm going to put it at 0.05, and we'll do 200 rooms. Wow, is it going? Oh my god. Yeah, so it kind of went straight through everything. Wow, is that fast? Wow. Dude, it's so fast. And adding a turn 2 here means that it's already past the room model. It's already past base plate. Already past the previous room and stuff. And this is going to be for all the extra objects, essentially. No, it will not. What the heck? And apparently I cannot get it to do it. I guess I'm like very stupid or something. So literally just like have it reject everything except the previous room and itself. So that way it won't go through any of these. So let's see if that works. Yeah, it does. Cool. Let's go ahead and run it here. And I'm just going to slow it down, honestly. Dude, procedural generation is so cool. Oh, look at that. None of those are colliding with each other, by the way. Look at that. None of those collide with each other. Not a single one of these are colliding with each other. Not a single one collides at all, which is kind of crazy. But hey, it's cool and I like it. and they're not colliding with any of this either, by the way. Look at that. His head's just barely there of the NPC dude. Oh, that's that. Procedural generation. I'm going to take thumbnail screenshots now. That right there is procedural generation. So the initial idea, it's not too complicated. But adding that one feature, which is the recursive backtracking, essentially, does kind of add a slight bit of complexity to it. But the essential idea to understand is that if the path is colliding with anything, like essentially getting its future position and checking if it collides with anything. If it does, we simply want to go back, try a new one, see if that works, try again. I'm going to do it for all of them. Let me switch them up a bit so make sure that the same pattern isn't used twice. And if that doesn't work, we're going to backtrack to a previous one and try again. I was going to take a thumbnail screen. That was a pretty nice one right there. I really liked it. Oh, hey, this is a pretty good one. I like it. And it would be really funny is if we only gave it left and right turns, then it would be a straight line essentially. Or, well, not a straight line. It'd be really funny. But look at that. None of these touch ever. But yeah, that's it. I really like the procedural generation. I think it was pretty good. And yeah, the entire script, it's just 104 lines of code, by the way. It's just this entire thing here. And the main functions are just these. Shuffling it, overlapping it. Oh my god. Shuffling our candidates to generate, checking if they're overlapping with anything, and generating it in a recursive format, where literally that's all we're doing here. This is the recursiveness part here, and this part is the actual looping part here, where we're looping with then it's like a nested, not nested, internal thing. My vocabulary sucks, by the way. Hey, I like it, you know. It's literally as good as the... And also, I think what I'm gonna do is I'm gonna make this 10 seconds. You know, let people think about how the procedure gen looks like, you know. Though I really feel like there'd be a better way to test out the procedural generation rather than have it go through the entire spawner, because then it like interferes with the idea all the work being, because they're just gonna sit here and they're gonna be like, yeah, no, I wanna have it for 5 seconds. And just to make it a bit nicer, we'll move the procedural generation start point a bit outward just to reduce the chance of it coming back. And then they can watch as the procedural gen does its thing. And, you know, we got this. This guy, you know, look, you don't like, bro. He's just an example of someone who will constantly chase you and damage you. You know, this katana, I'm pretty sure we made the katana on day 2, by the way. And I don't think it works. And then the gun, obviously, this was an absolute failure of a day, by the way. This is terrible. The gun did not work at all. It was absolutely a mess. You know, this guy right here. Well, I think I should, like, make this thing do more damage. This does absolutely no damage. And you're not... Yeah, I'm gonna make this guy, we're gonna put him in his own little corner right here, you know. And then the boss, you know, the boss obviously, he's pretty cool. I like that. So, like, yeah, I mean, quick little thing of everything done. We have an NPC dialogue here, you know, who we can talk to. And then we have a stage thing. You know, this is really easy to make, right? And then we have an upgrading system where we can upgrade a object. And then this guy right here, a lot of people might not understand what he is, but this is the states manager. This is how we can describe how states will work with animation, essentially. Like, you know, walking, running, what the hell? Oh, wow, that generated. Like walking, running, idling. And then this door here, you have to buy a key. Oh shoot, it's not even appearing in my help bar. Wow, that's low-key crazy. It's not appearing in my bar. You can't open the door without the key, you know. And then this is an example of the dropping gems system. This is the watchdog NPC. These are the custom zones. These were really easy to make. I don't know why this was like a challenge, but this was really easy to make. This is like a poison cloud, and this is the right. Yeah, I'll look how to fix the inventory system. I don't know why. Honestly, the inventory system was an absolute failure. Enough of that. I'm out of here.